Welcome back. So in this video we are going to talk about linear motion. So as the name suggests, linear motion is just we are going to deal with straight line motions. See, for instance, you can observe, for instance, like how my pen moves here from left to right. This is linear motion. Okay, now we have various types of motion. We have linear motion, circular motion, simple harmonic motion. So this video will focus on linear motion. So we have to understand some key concepts in linear motion. So for we have distance, and we have displacement, you see. Now these ones are tempting to confuse. They're just distance. These are just like the separation between 2 points. So for instance, we have this one and this one. See, this is house A maybe, and this house, let's call it B, and this is the road to go from this house to this house. Okay, so here there might be forest, buildings, and some things like those. Now distance, if you're told go to, maybe at this point you want to go to this point B, so the distance is this whole length here that will cover. So this whole length here is what is called distance. But the displacement is linear, is the shortest route, like the linear route between 2 points. So instead of taking all these paths, the displacement, it's just straight, the distance of separation, ignoring the path. So this is the displacement. Okay, so that is the displacement, and that's how distance differs from displacement. So again, in linear motion, we have speed. See, we all have ever heard of speed, like how fast something goes, but we need to mathematicalify it. I'm sorry, that's my new term. We need to express it mathematically in terms of a formula. Like how can we show that this speed is more than this speed? Exactly, by using a formula called speed equals to the distance covered over time. Okay, you see, so it's the distance covered per unit time. Okay, so if someone is fast, that means he covers large distance in a small time. That's how we measure speed. But in terms of as a vector quantity, we have velocity, like how we have distance and displacement. Now velocity is then the displacement on time. Okay, so velocity is the displacement covered over time. Now we also have acceleration. Acceleration means how fast something is changing its speed. Maybe if you're watching soccer, football for some people, yeah, you can see maybe this player has high acceleration, means he can increase his speed from rest and explode to a very high speed within few seconds, and some they take time until to reach at a high speed. So it's like the rate of change of speed. How can you change your speed? Like for instance, the trains, when they hit their brakes, it takes a long time until they come to rest. So that means their deceleration, which is just like decrease in speed, then it's very low, meaning that they take a lot of time to change their velocity from high speed to zero, different from how cars do it or human beings, right? So acceleration then is the change in velocity. It's a vector quantity, so I use velocity over time. When I say change in velocity over time, let me now use acceleration is a and v is velocity. Acceleration then is v minus u over time. This v then, it's the final velocity. This is the initial velocity of the object. Okay, Okay, now having knowing those key terms or definitions, let's get to the formulas of motion, of this linear motion. So the first formula is this one. We already have it. Now we normally express it in terms of v. So we have a equals to v minus u on t. Okay, so t multiplies here, so at equals to v minus u, so v equals to u plus at. Okay, so that's the first formula of linear motion. Now let's go to the second formula. Now from the first formula, let me write it here. V equals to u plus at. This one is the first formula. We can, what if we need the displacement? Displacement is normally shown by letter S. Displacement is normally shown by S. So we will need to find the displacement. Remember, velocity equals to displacement over time, right? Speed of displacement over time, so S on t. But we want to create a formula of displacement including acceleration. And remember, acceleration means there is a change in velocity. So velocity is changing at a certain rate. Now that means if the velocity is changing, we will need to find the average velocity throughout the motion. So this formula will hold only for average velocity. When I speak about the average velocity, so this one is average velocity. It can be given in this formula, but the normal final velocity, it's v equals to u plus 8, but v average is displacement over time. So average velocity, again, that means, as we know, average, I am to express in terms of final and initial velocity. It's final velocity plus initial velocity over 2, right? Like how we find average. Then equals to s on t, displacement over time. Okay, so I make s the subject because it's the one that I want to find, right? Okay, I want to find the value of s, so I multiply by t here. It becomes s equals to v plus u t on 2. Okay, but we do have already the value of v, final velocity, is u plus at. So displacement equals to u plus at, right, plus u times t on 2. Easy, right? Okay, so s displacement equals to u plus u, it is 2u plus 80, okay, times this t outside on 2. So the displacement s equals to 2ut plus 80 squared on 2. Okay, so the displacement s equals to, I divide by 2 here and here, so here I'll be left with ut plus 80 squared on 2. So the second formula for linear motion equals to ut plus a half at squared. Okay, very easy. So you have to know it also. Normally hand in solving a lot of equations on linear motion. Let's get to the third formula. Okay, now I've analyzed those two formulas that we got. Now with the third formula, we start from average velocity again. We know average velocity, v average, let me write v average equals to v plus u on t, right, of which is displacement on time, right? So that means s equals to v plus u on 2 times t. Right, now I go on another perspective. I'm using t from this equation 1. I'm substituting the value of t here. Now from equation 1, it's just mathematics here. We have v equals to u plus at, right? So that means if I make t the subject, I'll take u here, it will be v minus u equals to at, dividing by a, t equals to v minus u on a. Okay, so I take the value of t here, so s be equal to v plus u on 2 times v minus u on a. Okay, so s will be equal to this times this is a difference of 2 squared, it's v squared minus u squared on 2a, the denominator. Okay, then I multiply it here, cross multiply v squared minus u squared equals to 2as. So that is the third equation of linear motion. So the third equation, I write it down here, it's v squared, tilt the camera a little bit, v squared minus u squared equals to 2as. Second formula, what does it state? S equals to ut plus a half at squared. And what about the first one? The first one is v equals to u plus 80. Make sure you have all these formulas in your head and stick around for the next video. We will be solving some simple examples on linear equations. Thank you very much. Make sure to subscribe to my channel.